Hello, friends. I got my hands on a small solar panel from AliExpress that was given to me for testing. But since the topic of home solar power generation is becoming increasingly popular now, I decided to make a short review of it. Let's see what kind of panel this is, what specifications are claimed for it, how it is connected, and most importantly, what you can actually get from it in real conditions. Not in ideal laboratory scenarios, but roughly the way it might be used at home, on a window, on a balcony, or to power some small devices. Generally speaking, I would divide home solar power generation into two major directions. The first option is a series system, several full-size panels, total power in kilowatts, proper installation, cables, protection, and a hybrid inverter that can work with the grid, batteries, and solar panels. And honestly, lately I myself have been looking more and more closely in the direction of such a system, especially after buying and installing a hybrid inverter. There have already been reviews of it on the channel, and I will leave links to them in the description. And the second option is exactly these small compact panels. Essentially, it is an almost portable format. It can be mounted on a window, on a balcony, quickly connected, and, if necessary, just as quickly removed or moved to another place. Here we are no longer talking about powering the whole house, but about small practical tasks. For example, recharging a battery for backup power for a router, a surveillance camera, some sensor, emergency lighting, or another low-power load. Another scenario is direct charging of smartphones or a power bank through the controller's USB, which receives power from the solar panel. This is exactly the kind of panel we are going to look at today, conduct several tests, and try to figure out how much the real performance differs from the claimed specifications, and whether such a device makes any practical sense at all for home use. And before moving on to the details, as usual, I ask you to like this video. It will help other people who are interested in this topic find it, and subscribe to my channel if you have not done so earlier. Now let's move on to the stated specifications. Since I did not buy this panel but received it for testing, I am not tying the exact product listing to one specific seller. Instead, I found several visually identical panels on AliExpress. They match the sample I have in terms of construction, size, and package contents. I will leave links to several options in the description. As for the claimed parameters, everything here is quite typical for this class of devices. Sellers list the power differently, usually in the range from 10 to 20 watts. The operating voltage is 12 volts. IP65 protection is also claimed. The maximum current, depending on the version and the seller's description, is listed from 0.8 to 1.6 amps. Such panels are sold both separately and in sets with simple PWM charge controllers. Moreover, the controllers shown in the listings vary widely, from 10 to 100 amps. In my case, the kit included a controller labeled 80 amps, and we will return to it separately. The kit comes in this ordinary box made of recycled cardboard. The identifying marks include a small sticker on the side. The sticker mainly contains service information, the manufacturer, address, markings, importer data, and other mandatory designations. The only thing useful for us here is perhaps the model, FC079. But there are actually no technical specifications of the panel itself on the box. Neither power, nor voltage, nor charging current is indicated here. Inside, everything is packed quite simply. At the bottom, there is the panel in a soft protective film bag. On top of it, the simplest and cheapest PWM controller and several wires. As I said before, in most cases you can choose either just the panel or the panel together with the controller. The panel is made in a rigid. The solar cells on the front are covered with a protective layer, and there is an aluminum frame around the perimeter. In appearance, everything is quite neat. There are no obvious distortions, cracks, or any rough defects on the front side. The panel is small. It can be placed on a windowsill, mounted on a bracket, or taken out onto a balcony. The kit includes this solar charge controller. It is one of the simplest and most inexpensive options that are often found in such sets. This is a PWM controller. In short, it connects the solar panel to the battery in pulses and works quite simply. More advanced MPPT controllers can find the optimal power point of the panel and, thanks to that, usually use its capabilities more efficiently, especially when the panel voltage is noticeably higher than the battery voltage. But in inexpensive kits, they almost always use PWM because it is much cheaper. The kit also included these wires for connection. In my opinion, they are very thin. They clearly saved money on this as well. Although the currents here are small, and specifically for this panel there most likely will not be any critical losses over a short section. Still, I would not consider these wires a good option for permanent use. Let's start with the dimensions and overall design. The panel is indeed compact, about 33.5 by 20 centimeters. That is, this is not the kind of module for which you need to think through a serious roof installation or a separate frame in advance. It fits easily on a windowsill. It can be mounted outside the window, on a balcony, or temporarily moved to wherever there is direct sunlight. At the same time, the frame is rigid and aluminum, so the panel does not bend and keeps its shape like a small classic solar module. On the backside, everything is also as simple as possible. Here you can see the rear wall of the panel, a small junction box, and a long wire that was already installed by default. At the end of this wire are two crocodile clips. Obviously, the idea is that they should simply be clipped onto the battery terminals. And honestly, this is quite a strange solution. In such a setup, the battery should be charged not directly from the panel, but through a charge controller. It is the controller that should monitor the voltage, charging mode, and load disconnection. Therefore, the crocodile clips directly on the panel wire look more like a maximally simplified, out-of-the-box option, and I would not recommend using such a setup for permanent operation. If you remove the cover from the rear box, inside you can see screw terminals to which the leads from the panel itself and the outgoing wires are soldered. And here an unpleasant nuance was discovered. The plus and minus markings on the plastic part near the contacts are incorrect. According to these markings, it turns out that the plus is on the black wire and the minus is on the red wire. But in reality, it is the opposite. The red wire is plus, the black wire is minus. That means you cannot rely only on the markings inside this box when connecting it. Before use, you should definitely check the polarity with a multimeter. Now let's take a look at the included controller. It is small in size, about 14 by 7 centimeters, with a plastic body and mounting ears on the sides. On the front panel, there is a small screen, 3 control buttons, and 2 USB ports. At the bottom, there are screw terminals for connecting the solar panel, battery, and load. The markings are printed directly on the body. Panel on the left, battery in the center, load on the right. On the side of the body, there is a sticker with the claimed specifications. The controller is designed to work with 12 and 24-volt systems. The maximum voltage from the solar panel is listed as 50 volts, and the rated current is 80 amps. To be honest, I would treat such figures in inexpensive controllers like this, to put it mildly, with caution. All connections are made through ordinary clamping screw terminals. Access to the screw heads is from the front side, and the wires are fed in from the bottom. And these terminals are clearly not designed for currents anywhere near 80 amps. 10 to 15 would be good enough. The controller is disassembled very simply. On the back side, it has a metal cover held by 4 screws. There are no seals, latches, or any complex construction here. We unscrew the screws and get access inside the body. Under the cover is the main control board. It is installed inside the body and additionally secured with 1 more screw. Let's take it out and look at it in more detail. The front side shows the main control elements: the display, 3 buttons, USB ports, the screw terminal block, and a small DC-DC section for powering USB. As I said, the claimed 80 amps on the controller body looks, to put it mildly, optimistic. Judging by the size of these screw terminals and the overall design, this is roughly a 10 to 15 amp level, and that is only with proper tightening, good wire, and without prolonged operation at the limit. On the back side of the board, you can see the power section, wide tinned areas, jumpers, and components covered with thermal pads. This is done to dissipate heat into the metal rear cover. And here, the controller does not give the impression of a device capable of handling 80 amps in real operation. Although for our small panel this is not a problem at all, it physically cannot produce such currents. Before the testing began, I desoldered the standard long wire with crocodile clips because it is not suitable for a proper setup. Instead, I soldered 2 short and thicker wires to the contact block. Let me remind you that in my sample the plus and minus markings on the plastic were swapped, so I kept the original connection logic. These 2 wires were then connected to the solar input of the controller. Now we move directly to the testing itself. First, I simply checked whether the panel and the controller worked at all. I took them out onto the balcony, turned the panel outward, and connected the controller. At the moment of filming, there was still no direct sunlight on the panel. With the way my balcony is positioned, it only reaches here in the second half of the day. But even in such conditions, the panel was already producing voltage. The controller shows 13.7 volts, and the multimeter shows practically the same, 13.75. So at least in terms of voltage, the controller displays the data quite adequately, without any noticeable discrepancy compared to the external measuring device. Next, I checked the controller's USB output. For this, I connected a small USB lamp with a power of about 1 watt. In the frame, you can see that it is lit, but that does not mean the power supply was stable. In reality, the lamp was turning on and off with a period of about 2 to 3 seconds. That is, at that moment, there was already enough energy for the controller to try to start the USB output, but not enough for stable operation even of such a small load. To check the USB output, I decided to use an FNB58 USB tester and an electronic load. I set it to the minimum mode available on it. It came out to about 1.7 watts at a voltage of around 5.2 volts. And this is what the test bench for checking the charging of a 12-volt battery looks like. I added a model energy analyzer to the circuit. It allows me to see not only the current voltage and current, but also the power, as well as the total amount of energy that the panel manages to transfer during the test. As the battery, I use a 12-volt lithium iron phosphate battery with a capacity of 6 amp hours. Before the test, I partially discharged it so that the controller would have somewhere to send the energy. At the moment of connection, the battery voltage was about 12.8 volts. The testing itself eventually stretched over 2 days because it was not possible to carry out all the measurements in one go. On the first day, I started with the controller's USB output. For this, I took the panel out onto the balcony and selected the optimal position for it, an angle at which the controller displayed the maximum voltage. The test was carried out in direct sunlight. First, I connected the USB tester without a load to see what voltage appeared at the controller output at all. According to the tester readings, it was slightly above 5 volts, so the controller does form the USB output normally. But strictly speaking, this is not exactly an open circuit condition. Part of the energy is still consumed by the controller itself and by powering the tester. But problems started when I connected the electronic load. Let me remind you that the load was set to the minimum available mode, about 1.7 watts. But I was unable to achieve normal simultaneous operation of both the tester and the load. As soon as I connected the load, the USB tester screen simply went dark. Most likely, at that moment the voltage at the controller's USB output dropped so much that the tester itself could no longer continue operating. The load itself somehow tried to work. Its fan started spinning, but unevenly, in jerks. I also tried the USB lamp, the same one I had used to check basic operation. In direct sunlight, the lamp shone quite evenly and did not go out. But the tester could not start with it either. Let me remind you that its power is about 1 watt. Once the load was disconnected, the tester started immediately. So the conclusion about the USB output is this. I would not particularly rely on it for charging gadgets directly. The voltage clearly sags, and stable operation under load could not be achieved. The next day, I assembled the test bench for checking battery charging and installed it on the balcony early in the morning. The task was simple, not to catch some short peak moment, but to see how much energy this panel could transfer to the battery over a more or less realistic daylight day. So I left the whole setup running until evening. Let me once again remind you of an important point about the test conditions. In my case, direct sunlight reaches the balcony only in the second half of the day. That means for most of the time, the panel was operating far from ideal conditions, but rather the way it might realistically work when installed on a window or a balcony, first in diffuse light, then under direct sun, and closer to evening again with decreasing illumination. Without direct sunlight, the result was expected. The controller showed the battery voltage, but there was effectively no charging current. The analyzer shows 0 amps and 0 watts. That is, in this position the system sees the battery, but no real energy transfer takes place. This clearly demonstrates an important point. Just a bright day is not enough. You need direct sunlight, and preferably for as long as possible. And the second point is that even when the sun had already moved to the right side, and started falling directly on the panel, the conditions still were not ideal. That day there were variable clouds. That means part of the time the panel worked in direct sunlight, and part of the time the sun was covered by clouds. And this is very clearly visible. As soon as the sun goes behind a cloud, the output drops sharply. On the one hand, this makes testing more difficult because the readings are constantly changing. But on the other hand, this kind of mode is much closer to real operation. After all, at home the panel will almost never stay all day in an ideal position under a clear sky without a single cloud. Therefore, the results that follow should be viewed specifically as a practical test under ordinary conditions, not as a laboratory maximum that can only be obtained under perfect sunlight. When the sun finally came into the panel's direct line of sight, the battery charging started. I periodically came over to the setup and looked at the analyzer readings, and they changed very noticeably depending on the cloud cover. In this shot, you can see a current of about 0.33 amps and a power of about 4.2 watts. This is not completely clear direct sunlight, but sunlight behind a small cloud. If the cloud cover became a little denser, the power easily dropped by about half, to a level of around 2 watts. And when the sun was covered by a denser cloud, the output could stop completely and fall almost to zero. The maximum I managed to catch during periodic checks was 0.41 amps at a voltage of 12.97 volts. That means the power came out to about 5.3 watts. At that moment, the panel was under direct sunlight, without clouds. And here it is possible to estimate the discrepancy with the claimed specifications. Let me remind you that in the descriptions of similar panels, the power is usually stated as 10 to 20 watts. But in my test, the maximum value I saw turned out to be about 2 times lower than even the minimum claimed power. Of course, I do not rule out that at some brief moments the power might have been a little higher, but hardly by much, because this shot was taken precisely under direct sunlight that was not obscured by clouds. Therefore, for practical calculations, I would use a figure of 4 to 5 watts. By the end of the day, the sun had already gone, and the output dropped to zero again. The analyzer shows current 0 amps, power 0 watts. That is, the panel is no longer delivering anything, and the battery simply remains connected to the controller. But during the test, it was still possible to accumulate a result. The analyzer shows 0.737 amp-hours of transferred energy. Let me remind you once again that in my case, this was not a full day of direct sunlight. The sun reaches the balcony only in the second half of the day, and in addition, there was variable cloud cover during the test. If you switch the analyzer to watt-hours mode, you get 9.3 watt-hours of energy for this test day. For a battery with a capacity of about 72 to 77 watt-hours, this is around 12 to 13% of the full capacity. That means this panel certainly does not fully charge such a battery in a day under my conditions. If you place it in a better location where direct sunlight shines almost all day and the cloud cover is low, I think this result could conditionally be multiplied by about 3. That means, in the most optimistic case for a summer day, I would expect something in the range of 30 watt-hours, maybe a little more, but not significantly. And that is still less than half the capacity of such a battery. In principle, this is more or less what I expected. While I was looking for offers for these panels on AliExpress, I had already seen reviews where people wrote about the claimed power not matching the real figures. In some cases, they were talking about power at around 4 watts. And essentially, I ended up with a very similar result. True, this applies specifically to operation through the controller's battery output. There, the panel really was able to deliver several watts, and the maximum I saw was about 5.3 watts. But questions about the USB output still remain. Because with that kind of power, there should have been enough energy both for the tester and for the electronic load to operate, and not necessarily only in the absolute minimum mode. Most likely, the problem here is not so much with the panel itself as with the quality of the USB converter inside this controller. Without a load, it shows about 5 volts, but even under a small load the voltage clearly sags, and stable operation could not be achieved. Theoretically, this panel can be used to charge something low power in a 12-volt system. For example, a small battery for emergency lighting, some simple backup power setup, or a power bank that can charge directly from 12 volts. In field conditions, with good sunlight, it would be possible to accumulate enough energy in a day, at least to charge a smartphone. But there is another point here as well. The panel is rigid, not foldable, and not flexible. Carrying around a solar module measuring about 33 by 20 centimeters in an aluminum frame is not the most convenient option. There are more suitable foldable or flexible panels for hiking. So, honestly, I do not see any particularly practical application specifically for this panel, except perhaps as an inexpensive option to experiment with. Understand the basic operating principle of a solar panel and a charge controller and estimate the real figures. But I hope I have already drawn the main conclusions for you. That is all. I hope the video was useful and interesting for you. I would be grateful for a like. It helps promote the video on YouTube. If you have not yet subscribed to the channel, now is the perfect time to do it right now. In the description under the video, there will be links to such panels, to my social networks, my Telegram channel, and a group for communication on smart home topics. Join us. It will be interesting. Thank you for your attention. See you again. Peace to everyone.